Hello, sir. Shall we start the session?
Okay, sir. Okay, sir. Go ahead.
Okay, fine. Thank you. So, good afternoon, all the participants. Today, we are going to start the lab session on exploratory data analysis. And now we are going to deal with the real-time data, that is on water pipe maintenance shutdown prediction data, right? So, the goal of this task is to predict the shutdown of a water pipe, so when it goes into maintenance stage. So when a water pipe goes into maintenance, can anybody please tell me when a water pipe goes into maintenance? First of all, is my voice audible to all of you?
Yes, sir.
Yes, sir. It is audible, sir.
Fine. So please let me know when water pipe goes into maintenance.
Due to corrosion or
Those
due
things,
to hole.
fine, sir. Please type them in the chat box.
Due to long time using also, sir.
Okay, sir. Fine. Please type into the chat box. I would like to see the responses, different responses from the participants. So, due to corrosion, wear, damage, the water pipe will go into maintenance. So, okay, these are the three reasons. There could be more than these three reasons, there could be other reasons for which the water pipe goes into maintenance. So long time using and effect of corrosion. So fine, this is uh, what type of maintenance are preventive or breakdown. So shutdown, strictly speaking, it is shutdown, right? When it is when we, in what situations the water pipe will be shut down, right? So we need to predict that. So predictive maintenance of water pipe. So leaks, when leaks will occur, when leakage occurs in the water pipe. That's what. When my another question is immediate question. When the pipe gets damaged, so leakage happens when pipe gets damaged, water pump gets damaged. So when the water pump gets damaged, so you are saying it is with use. So only with usage the water pipe gets damaged, or are there any other reasons, factors leading to damage of water pipe or water pump? Right. So one of the different reasons is like pressure. You are saying yes, it's a good answer. Flow control is another answer. So lots of wear leading to damage. Yes, is another answer. Right. So flow control, pressure of the water, right? And why can't it be the temperature of the water, or it could be the pump pipe components? Could there be a damage of the water pump due to temperature of the water? Is that right? So particle collected or clogged, right? You are saying clogging of the water pump, right? Fine. So can I consider temperature of the water or the temperature of the water pump? Variations in the temperature of water pump. Can it be? Yes. You are saying high voltage burning. Yes. So I could see there are so many reasons that were specified by the participants here. All the reasons are actually true, which leads to what is called as shutdown of the water pump, right? So here these values are actually continuously monitored through sensors. So at industrial water pumps, let us take the example of industrial water pump. These industrial water pumps are attached with so many sensors, right? Around let us say the number of sensors of around 49 to 50 sensors, right? So each sensor has got its own functionality to Like temperature sensor continuously monitors the temperature of the water and the components of the water pump, right? And this continuous monitoring of the temperature helps us to understand the desired operating range of the, let us say, desired range for the temperature, till how much temperature a water pump can get, what to say, can tolerate, right? Not only temperature but also you are saying the pressure, right? So pressure sensors will also be there, that will tell you what are the deviations that occur in terms of water pressure, incoming water pressure, right? So is it high pressure or low pressure, right? So is there accordingly the flow control, right? The flow control also is continuously monitored with the help of flow control sensor, right? Flow sensors, water flow sensor. So this water flow sensor helps to understand whether the flow of water is normally happening, or is the flow of water is less, or less due to clogging or particle collection in the water pipes, or the water equipment pipe, pump equipments, right? So all these things are the issues, right? Which can be identified through continuous monitoring of the water pump with respect to these parameters, right? So when sensors are providing these details, with these details in the form of readings, right? Continuous readings, and these readings will happen on a time to time basis, right? A daily basis, on daily basis. So this is a, let us say, time series problem, right? This can be formulated in the form of time series, because every day these sensors will record the values, right? Based on the water pump functionality, right? So yes, so now what we need to do is we need to identify or predict uh, when this water pump goes into maintenance stage. And when this water pump goes into maintenance stage, automatically the one of the decision to be made taken is to shut down the water pump, so that water will not get wasted and the damage can be reduced to a greater extent to the water pump, right? So to do this, first we need to collect the data, right? We need to collect the data. So for that, what we are doing is, I have shared the data file with you. The name of the data file is sensor.csv, right? The name of the data file is sensor.csv. And this data file has been uploaded into my Google Drive. And to this file I have drawn the shareable link, and this shareable link is shared in the morning session. But still, once again, for the purpose of lab, what I'm doing is I'm once again sharing this link with you people in the group, right? So that you can download this data file. If you haven't downloaded already, the instructions to download and upload into the Google Drive has been provided around 1 hour back with you people. So once again, for the sake of other participants who haven't followed the WhatsApp messages, so for them I am once again sharing this link here. So the participants are informed to download the data set from this link, right? And once you download the data set from this link, the next thing that we need to do is to log in into your with your Google account into the Colab environment and mount your drive, right? So once you download and upload into your Google Drive, your data file will be automatically reflected here, right? You see, your data file is already getting reflected here. It is shown here, right? So I would like to know from all the participants uh, the status of the availability of this data file in your Colab, right? I will give you 5 minutes of time so that you people will do this and respond to me.
If any doubts, you can ask Amma.
Yes, you can ask the doubts if you have any for during this process.
Participants, if you are having any doubt, you can ask Amma related to Colab.
Sir, is this Excel file visible in on the screen?
Yes, sir. Yes, sir.
Okay.
Sir,
Yes, sir.
some of the participants are telling that Excel file cannot be visible.
It is not visible. Yes, sir, the Excel file is visible. You are saying whether is it visible on the screen, or is it visible, is not visible at your location. So if that is the case, I will once again share the screen, right? Excel file to see. Now I think this Excel file is visible with all of you.
Yes, sir. Yes, sir.
Okay,
Yes, sir. I think this time it is.
right. Participants, please respond the status. I have mounted the drive, but drive folder is not visible. Just refresh. Uh, just click on the refresh icon so that your mounted drive will be visible. Okay, fine. Good. So I think almost Jupyter Notebook. Yes, you can use. This is for the participants at large. This is a convenient option that we have chosen to carry out the lab sessions. Fine. So good. No problem. In Jupyter also you can do. There will be minor what you say things that we need to take care of when you change the ID. Like you are moving away from Colab and you are entering into Jupyter. You can do that, but there will be some porting issues that we need to take care of. Right. So fine. So all the participants are informed to see this screen. So the data set that we have uploaded in our Google Drive is, when you open that data set, it looks like this, right? So if you observe, this data set starts with a serial number, which is not given in the form of an attribute name. The next immediate column is timestamp, right? Timestamp is nothing but the time, that date and time information uh, at which the readings have been recorded, right? So we have altogether from sensor 0 to sensor 51, uh, adding up to 52 sensors. So there are 52 sensors attached to this water pump, to the water pump, in order to continuously monitor by reading the corresponding values specific to that sensor, right? So you see there are different types of values available here, right? So if you see, interestingly, 15th sensor 15, nothing but the 16th sensor in the sequence, sensor underscore 15, that column does not hold any values. You see all the 9,839 values are empty. If you observe this, 15 sensor has no values, right? So what shall we do with this attribute? We will handle this attribute now. So after that, from 16 sensor 16 to sensor what you see underscore 51, there are once again sensor readings, right? So, and finally, if you observe, the machine status is labeled as normal. Now, for these sensor readings, the label associated is normal across all the rows or all the records. For all 9,839 records, the label associated with it is normal, which means the sensor, the machine status, the water pump is seem to be normal, right? Water pump is seem to be normal, but still we can understand, we will understand whether actually the water pump is normal, or whether it has any defect in it. All those things will come to know when we do exploratory data analysis on the data, right? So the see here the timestamp, for each second the readings are took. So at the 0th second, first second, second, third second, and so on up to, right, across for entire 24 hours, the readings were taken, right? So you see the date is changing only at which value? At 23:59, I think. At 23:59 we go here. So here the value gets changed. You see, here the value is changing, right? At 1441 first record, the value is actually changing. That means the date is changing. So these are right. So every second values, for right, for all the 24 hours. So leading to so many rows, right? So that's why these many readings. How many days? For how many days the readings are present? Actually, if you see, interestingly, the number of readings taken for only for 7 days, and not up to entire seventh day, up to 758 only the readings were taken, right? So now by considering this data set, what we are doing is we are trying to understand. 1 minute, I would like to share the screen. We'll try to understand whether the machine status is normal or it is abnormal. Machine in the sense here it is water pump, right? So see here. So you would like to predict whether the pump may be shut down for a period of time based on input signal of the sensors. That is what we would like to do. We would like to predict, right? The task of prediction is performed with the help of supervised and unsupervised learning algorithms. So we are now interested in understanding the sensor attribute data, and how these attributes are correlated among themselves, so that we can make groupings among those attributes and come up with a good insight saying that because of these attributes, it is possible to predict efficiently when we carry out machine learning, right? So now the input parameters for the model or of the model are sensor parameters, nothing but the sensor attributes. So now the input parameters or input variables, both are one and the same. Technically, we are speaking these as input parameters, right? So how many sensor attributes are there? 52 sensor attributes are there, and the output of the machine learning model will be a single parameter, which is nothing but status of the machine, right? So here it is seemed to be normal in the data set, but there are three levels for this particular status, right? The pump operating state is has three values, right? So 0 for shutdown, 1 for normal, and 0.5 for recovering, right? Right now, please tell me what is the class label attribute. Is it what type of attribute? Is it a categorical attribute or is it a continuous attribute? Right? Please respond in the chat box. So it is categorical attribute, right? Categorical. Fine. Yes, three students have, three participants have said that it is categorical. Good, correct. So categorical attribute with three values, right? Three values it is holding. But for the sake of what we say, but for the sake of programming purposes and for the sake of easy mapping purposes for machine learning task, we are establishing a mapping between the string and the corresponding value, right? So shutdown stands for 0, normal stands for 1, and recovering stands for 0.5, right? So strings are discrete, but we are using values instead of strings, right, for easy mapping and faster analysis, right? So now what we are going to do here, now we are going to analyze the correlation between these sensors and determine which sensors are most important, right? Which sensors are most important for the sake of finding out the output, right? So our goal is to reduce the number of sensors input parameters to have more accurate prediction results, right? With less input parameters, is it possible to achieve accurate predictions? So that is what is the goal of this entire notebook, right? So this is not the concept of PCA. In PCA, what we do is we will reduce the number of dimensions, and we will transform the dimensions in such a way that the transform dimension with those transform dimensions also we can actually reconstruct the original data, right? We can reconstruct the original data with the help of those transformed dimensions, and of course we are reducing them, right? Here this is not the case. We are totally finding the groupings of those sensors which are highly correlated in nature, so that these groups of sensors are only used for the sake of finding the health of the water pump, right? So so in my shared drives, files are not visible. uh, yes sir, you just refresh it. I think you might not have uploaded into your Google Drive the data set. I request you to upload the data set into your Google Drive, right? So that it will be uploaded. And here in this screen, if it is not visible in this particular window, you just click on this icon, refresh icon, you will be able to see, right? Please upload it in the Google Drive. Thank you. Fine. Now you see, we are importing uh, two attributes which are required for our EDA task. That is NumPy attribute as well as Pandas attribute. Sorry, packages, NumPy package and Pandas package. Right? We are using these two packages for the sake of pre-processing the data. For the sake of analysis, we can import matplotlib also. Right? We can import matplotlib also. I think at a later point of time, we are actually importing that matplotlib. See here. So we're importing this at a later point of time. This is the beauty of programming with Python. Wherever it is required, you can import that package at that location directly. Right? There is no hard and fast rule that the package should be imported at the initial line itself. Right? So now, so you can import the package here also. There is no issue. So what we are doing, we are importing NumPy package and Pandas package. We know NumPy package is for numerical operations and for doing basic linear algebra. This was covered early in the last lab, right? In the yesterday's lab, we have used the NumPy package and to create matrices and vectors, and we have calculated the dot product across in between those vectors and matrices. And we have done so many things at that point of time. Right? With Pandas, as I told you, Pandas is used for holding the data that is coming from the external environment into the Python environment in the form of a data structure, right? So we can do all sorts of operations on the table Pandas data structure to view only limited number of columns, or to extract limited number of rows, or to show the first 5 records from the data frame, or the last 5 records from the data frame. All those things we can perform, right? So in addition to this, we are also using this, but this is not required actually, strictly speaking, because we are simply using CSV file to read the data, right? To collect the data and read the data. So we are using Pandas, what you say, alias name, and on that we are calling the method read underscore CSV. So this asks for providing the path or the name of the CSV file, to specify this name of the CSV file here, and so that the data gets available in your data frame. This is your data frame, please. This is assigned to a variable called data. For clarity purposes, you can use the name data frame also, right? You see, when I place the cursor on that, it is showing you what type of structure it is, right? It is a data frame structure. So you're holding the entire sensor data in this data frame for the sake of analysis purposes. Right now, once you load the data into this data frame, as we have seen from the data set, right? This data set contains empty column, which is sensor underscore 15, which has no values. So how do we deal with this particular column? And are there any other issues regarding the data which is not possible to understand just by looking at it? We will now see. Right, immediately, as I told you, this data must be cleaned, right? This data must be pre-processed and cleaned for overcoming the what you say, errors and handling the missing values, right? So here, uh, the this particular file, this particular author of the data set informed that there are 7 system failures over 1 year, which caused serious problems, right? So these system failures, just by looking at the sensor data, is it possible to understand or not, is the important thing, right? So it is not possible to understand, right? If that sensor standard operating range is available with you, then it is possible to know whether that sensor has provided you with the wrong values or correct values, right? These values are actually influencing the status of the water pump, the health status of the water pump, right? So some of these sensors are actually providing wrong values, right? So that it has caused system failures for 7 times in 1 year, right? So now what we do is we will quickly go through the shape of the data first, and then what we do is we will try to what you say, plot the box plot on these attributes for at least for some, for few of the attributes, so that uh, whatever the author has informed here, reported, is it true or not with respect to the uh, attribute values will be easily understood, right? Now you see, upon the data frame, what we are doing is we are calling the attribute called shape, right? So this data dot shape returns the uh, size of your data set, that the size of the data set is measured in terms of number of rows and number of columns, right? So the number of rows are 2,20,320 and the number of columns are shown as 55. Is it true or not? Just you'll run this. So I think this step has not executed, so we'll run on this. Right, it has executed. Now we'll run. So it is showing me only 9,809 rows and 55 columns. Right, this is altogether a different data set, I think, which I haven't used for running this, but still we'll run with this, no problem. We'll try to understand the other file. Okay, fine. Sir, just we'll run the number of columns here to show. Yes, there are totally 52 attributes, 52 sensor data, and there is a the 53rd attribute called machine status, and there is a 54th attribute called timestamp, and there is an unknown attribute which is nothing but sequence number, your 55th attribute, right? So I think there could be some other attribute altogether. I'll just check it. One minute. Give me time. 1 minute. My drive sample data is not here, but still. mm, mm, Electric drives. Pre-conference workshop symbols pixel. Fine. No issue. Continue with this. No issue. I think. Okay, no problem. We'll continue here. Fine. So what we do is we will try to describe the data. Description of a data means nothing. Means what? It is summary, right? We are trying to find the descriptive statistics from the data, right? So if you don't use transpose, what happens? You only see here. So I'm simply removing this transpose and simply I'm running this file. You see, right? So for each attribute, you are able to see these standard columns, right? Standard measures, statistics, right? So what is the total count of for each attribute? What is the mean value? What is the standard deviation? What is the minimum value? What is the maximum value? And the 25, 50, and 75%. This is your what you say 5-point summary. and this this is seem to be easy to understand with respect to each sensor, right? So what happens if I do transpose? So now rows have become columns and columns have become rows, but this is seem to be very heavy because these attributes are listed in the form of rows. Better we see the values in the column wise. So before seeing that, you see sensor 15 has no values, so not a number, right? So sensor 15 has null values, right? So this is the important observation. Of course, we have already observed from the data set itself earlier. So it has null values. So how to handle these null values is the important point for us. So for understanding how many null values are there, right? What we are doing is we are simply using the Boolean method called is null, and we are summing all the null, counting and summing the null values, right? So in sensor 30, sorry, in sensor second sensor whose name is sensor underscore 1 has 30 null values, right? And in sensor 15, as we have already seen that there are 9,839 null values, right? And remaining all sensors have zero null values. That means all the values have been filled, right? Now, just by looking at the Excel sheet data, did we observe any null values in second sensor? Right? Is it easy to understand, or is it easy to identify the null values in second sensor column? Just we look at it, that we look at that particular now. See here, I will just share that Excel file once again with you, so that you will understand how important these descriptive statistics or summarizing the data is all about, right? Where it is, the Excel file archive. So 1 minute. Now this is the big value, right? Okay. Right. You see here, I think I need to share the screen. Cancel. Uh, yes, you see, it's in the second sensor, are there any null values? It is showing me there are 30 cells which are empty in the second sensor column. So I am simply scrolling down to find out the null value. So it is practically not possible with these many number of values. The only trick that is easy to identify null values is to find and replace the space. So what do you want to find space, right? Or what do you want to find, what do you say, space, and what do you want to replace it with? To not to identify whether the space is there or not, just replace it with comma, right? Find all, just click here, find all. Yes, we could able to see the null value here, right? In 2002 location, that is 2003 value measurement, we have null values. Then followed by here this and so on, and this continued up till 2031, right? So just click on this. It is showing the null values beyond this also. Fine, this is your 2031. So these are the locations where the values are not available, sensor readings are not available, right? So yes, we could able to understand the significance of summary statistics, so that whenever, if you have if you have done any overlook, right, on the data, the summary statistics help to identify uh, the crucial piece of information like missing values in this fashion. right? Till here, are there any doubts, participants? Are there any doubts? Yes, the bigger file is in archive.zip file, but okay, fine. We are running with this small file, and we'll try to understand how the readings help us, right? Fine. It is clear till now. That's what, sir. We will continue from here. Just to, I would like to know whether the participants are with me or not. Any doubts,
Yes,
participants?
sir. No doubt.
So no doubts. Okay. Okay, fine. So we'll continue from here. Okay. So fine. And now we understood that there are two sensors in which null values are present. What we do is we will try to uh, drop those empty values. So let us remove all the NN columns and all the columns having zero standard values. So in this particular example, or in this particular data set, we are not at all interested in this particular column, right? Because this is holding only sequence numbers. So we need to drop this or eliminate this from the analysis. So we are removing this. So what is the advantage of reading entire data into pandas data frame? Can anybody tell me? Now you are removing the columns themselves, right? You are directly removing the columns. If you are doing the same thing on directly on the Excel data, what happens? If there is no option called pandas data frame, and if you are simply removing the columns from the Excel, then what is the problem that you raise, that you have? Yes, please tell me. Yes, anyone? The columns are deleted directly from the Excel sheet, right? And these columns might not be visible at a later point of time, right? So your data is now safe, right? Your data is now, Excel data is now safe, and your entire data is now present in the Python programming environment, altogether, which is nothing but a replica of your entire data, right? So like this, your data is now safe, and you are only working on the replica of the data in the programming environment, right? So fine. So now you see here, we are removing this first column, which is useless column, and then we are not interested in this timestamps, because we have understood that for every second the readings are obtained, and then we would like to uh, remove sensor 15 uh, uh, from our analysis. We would like to remove sensor 15 values from our analysis, and all the sensor 51 and sensor 50 data are already available, right? So we are retaining them here. We are retaining them. Okay, 1 minute. There is a thing. So we would like to retain sensor 50 and 51 in our analysis, right? And what do we do with these 30 values? Yes, how do we handle these 30 values is the question mark here. So first we will remove these things, right? We will remove these things. Nice. So now before that, before handling those 30 values, so we will simply check what is the shape of the data now. Data dot shape. Just run here. So from 55, from 58 columns, the number of columns have been reduced to 52. So we have removed 3 columns, right? We have removed 3 columns. So in SAR 15, you cannot do any imputation, or you cannot make the values, replace them with what you say, a mean value or median value or mode value. So we are simply removing this entire column because it holds no values. So then how do we deal with the sensor what is see sensor 15 sensor 1 column, right? So now, so we know, we will just what we do is data of, so on pandas, what you do is you can call on the attribute, right? Data of that attribute dot, there are no methods on this, so data, right? I think data dot head we know, so we will check data upon data, do we have any methods, right? Data dot, we have some methods here, these squares represent methods, right? So data dot, let us say we would like to find out the we would like to fill NA, data dot fill NA with what are the values we would like to fill NA with? Fill NA with NP dot mean. Do we have mean method? NP dot mean of this sensor 1, right? I would like to do this. It has showing me an error. It is showing me error, right? So mean of data of sensor 1, data of sensor underscore 01. Then why it is showing it is not defined. Mm. Mm.
Try using codes for sensor.
Which method?
No, codes for sensor. I think sensor needs to be in
Codes.
codes.
You are saying codes, right? I will try that. Mm. Okay, 1 minute. This is one here and one here. Yes, yes. This is what we are doing is we are filling NA null values, right? Filling null values, not a number values using the specify method. And what we are doing is we are calling mean method on the NumPy, what you say, NumPy package, and we are passing that sensor column, right? So that how those 30 columns will now get replaced with the mean value, right? So simply run, and what we do is just for the sake of clarity purposes, whether it has have done or not, we will try to create a new data frame for that, just to hold this particular column value, and we will check whether this happens or not. So name NP is not defined. Oh, so we haven't run this. Okay, fine. Now it will run. Yes, yes, it has executed. Just check new data, and is it possible to give range? New data of column range from 2001 to 2031. Is it possible to check or not? We will see. Yes, you see the sensor value has been appended, you see 49.001740, 49.248005. So the values have got appended. You see, the values have got appended. So any doubts here? From 2002 onwards, the values have got appended with the mean value of that column. Any doubts? Yes, please. Participants, if you have any doubt, please let me know. Yes, participants, any doubts? How did you define NP? So NP is alias name for the package NumPy. So we have already imported that package at the first in the first line itself. So import NumPy as NP and import pandas as PD. So we have imported these two packages, and it is possible to reuse this alias name wherever it is required in the programming. So what we are doing is we are utilizing that alias name, and upon that alias name we are calling the methods. Which method is suitable to do this? So we are using mean method. You are free to replace these missing values with median also, with mode also. It's up to you, right? The syntax for looking the only the sensor only a particular column is the name of the data frame, uh, in which you pass the name of the corresponding attribute in single quote, as one of the participants has informed. Use the single quote. So just use the single quote. And the method that we are use fill na. Just you see, fill na stands for filling the not a number values with some specific method, right? So yes, we have filled with the mean value. So I think, are there any doubts still? How 2000 value is different from 2002? Yes, you see Excel in the Excel file, from 2002, as the it is row number read by the Python in the Python, right? So it is 2000. From 2002 the values have been modified, which means these are the empty cells from 2002 to 2032 or 31, right? So if you just change it, you will better understand. 2002 to 2032. So you see 2002 to 2032, which is nothing but 31 or 30 values, right? Any doubts? What is the use of axis in drop method? So if you see, so axis is equal to 1, which means the first row. It is first row. In the first row, we are holding the names of the columns, attributes, right? Names of the attributes. From that column, you remove these attributes. You drop these attributes. You are informing the what you say interpreter, Python interpreter, to do that, right? And we are saying from that particular location only you drop it, right?
म्यूट कर देना ये बटन आवाज अच्छा
Yes. Any other doubts? So shall we continue from here?
Okay, sir.
Right. If you see, now we have appended the values in the empty columns, and then we will now plot the what you say sensor readings, which is in the form of a time series data, right? Which represents a time series data. Just we will plot them by using plot method. So, and this plot method, when we are using this plot method, as we are trying to plot all the sensor readings at a time, we are calling the attribute called parameter called subplots, right? So we are using the parameter subplots and making the value to be true. so that all the sensor readings are shown at a time, right? And this other attribute share value is true and figure size is 2050, right? So you see, when I run this, how the plots look like. So
இப்போ மத்தவங்களது அந்த இதெல்லாம் எடுத்து போகணும். அது இதுல இருந்து எடுத்து போட்டாங்களா? UMIS ல இருந்து அந்த அந்த ஸ்கிரீன்
so
ஓபன் பண்ணிட்டு போட்டாங்கன்னு போட்டுட்டே இருக்காங்க.
I request the participants to please unmute yourself.
ஏய் அது இல்லாம கூட பண்ணலாமா மேடம்?
இஎம்ஐஎஸ் நம்பர்லாம் பண்ணலாம். இஎம்ஐஎஸ் நம்பர் வந்து ஆந்திரா வந்தா தேவையில்ல.
ஆந்திரா
Hello.
பிஃபோர் நீங்க வந்து டிப்ளமோவோ 10th படிச்சதா தேவையில்ல.
எப்போ கொடுத்தா?
2018ல முடிச்சிருக்காங்க, தேவையில்ல.
Fine. So participants, I think you are able to see these plots. Yes.
Yes, sir.
So yes, so for all the sensors, the plots are shown here. Readings, right? Sensor readings are shown in the form of time series plots, right? If you observe carefully, sensor 19, 20 and 21, these sensors, the plots of these sensors are very much similar in nature. Is that right or not?
Yes, sir.
And 16, 17, 18 sensor 16, 17, 18 plots are also, they are similar in nature, right?
Okay, sir.
And if you consider 14 also, it is also same. 14, 16, 17 and 18, they are same. And what about sensor 1? As we have imputed, or we have handled the missing values with the mean value, you see there is a different way of visualize sensor readings visualized here in different way. But this visualization, if you observe carefully, in this particular region for if you compare with sensor 2 and 3, in this particular region, the peak value that is visible in this particular range of dates is same. Is that right? Are you with me, participants? From here to here, you can observe the peak, similar kind of peak, right? And if you still see carefully, sensor 1 and sensor 2 values are seem to be somewhat similar for some number of readings across the different seconds, right? So please keep in mind, or please write aside, what are the sensors, what are the readings of those sensors which are similar in nature, right? While we do observation. So here sensor 14, 16, 17 and 18 are similar. Pen unda? Okay. So sensors 14, 16, 17, 18 measures, what to say, the readings are similar across different timings. And 19, 20 and 21 are similar, right? Are similar. And if you see sensor 24 is also similar with 19, 20 and 21 sensor readings, but uh, the strength of the readings are high. You see this thickness, it is more, right? It is more, but still in terms of visualization, it is somewhat similar, right? Still, if you see carefully, 19 and 24 are similar, 20 and 21 are similar, right? 19 and 24 are similar, 20 and 21 are 24 are sorry 20 and 21 are similar, right? Then if you scroll down, sensor readings, sensors 31 and 32 are similar, right? Sensors 31 and 32 are similar in terms of visualization. Visual comparison I am doing here. Please feel free to ask doubts. And 34 and 35 are similar, right? 34 and 35 are similar. We will draw some conclusions here. You see why I am doing this similarity measurement comparisons. So you'll understand within a few moments. And 38 and 39 are similar, right? 38 and 39 are similar. And then 41 and 42 are similar, right? 41 and 42 are similar. Forty-three and 46 are similar. 43 and 40. Yes. Yes, please. Yes, please tell me. I think 48 and 51 are also similar. Participants, you also please let me know what are the similar sensors on the basis of visualization, time series data visualization. Please let me know. So I will type in the chat box. Please compare whether my groupings and your groupings are one and the same with respect to sensor visualization. 14. If I will mute, how can I reach out to you? Emblem 255. 14. బాబు కొద్దిగా ఏమనుకోకుండా తలిపేస్తావా? కొద్దిగా తలిపేస్తావా? డిస్టర్బెన్స్ వస్తుందంట. 14, 16. Thank you. 17 and 18, followed by 20, 21, then 19, 24, then 31, 32. Then we have 34, 35. Then we have 41, 42. Okay, 41, 42. Then we have 43, 46. 43, 46. And then we have 38, 39. Did I give 30, 39? 38, 39 also. 38 and 39. Then we have 48, 51. That's all, right? So please cross check with these groupings of the sensors on the basis of visualization. So we are about to complete this session. Please tell me, are these groupings similar with what you have done, with what I have done, right? With what I have done. So please take a screenshot. Print the screen. Right. Participants, please bear for another 5 minutes. We are about to complete. Right. So from this, what we are doing is we are grouping the sensors based on their similarities in the visualization purposes. Now, what we are doing is we are trying to find out the value counts with respect to the machine status. In this data set, all are said to be normal, but all are said to be normal. There is no way of dealing with the remaining values. What we are doing is we are simply eliminating the remaining conditions in the machine status, and simply we go through with only one choice, that is only one, right? Only one, and simply we will run this, right? And we will see the plot. So are there any obvious patterns are there in the plot? We'll just check it here by after doing this. I don't think there will be any obvious plots because all the values are said to be normal here. So come back to sensor 14, 16, 17, 18. So 14, 16, 17 and 18, you see, and now the inherent groupings will be 17 and 18. Still 17 and 18 can be made as a group. So 14 and 16 are somewhat different. If you see carefully, now they are somewhat different, right? The next order is 19 and 24. So 19 and 24, if you see, now both are different, 19 and 24. 20 and 21, they are most of the time they are similar, right? So we could see that some groups have been divided into still smaller groups with respect to sensor similarities, right? And what we are doing is we are grouping them and we are trying to reduce the data size. So what are grouped here? We will group sensor 17 and 18, right? We are grouping 17 and 18 sensors. Let us say data columns, operation sensor 17 and 18 will group, right? So just for the sake of this lab, we are grouping all these things. Delete and we'll just run this. So we'll use df0 here to plot. df0 subplots we will do. So see here, sensor 17 and 18 plots, they are now very much clear, right? So both the values, both the readings, sensor readings are very much similar. So visually, how the grouping is said to be correct now, right? Audio not audible, sir. Is my voice audible?
Yes, sir, audible.
Yes, sir. Yes,
So,
sir. Clear.
Yes, sir.
so yes, please see here. The visual way of grouping the sensor readings is said to be true now, right? Is said to be true. This operation is not required for us. 17 and 18 sensors are seem to be correct, right? Now you see how the shape differs. Now the shape is only 3 columns. So from where we have reduced to 3, from 55 columns, we have reduced to only 3 columns based on feature subset selection. This is known as feature subset selection. Now, what is the task that we have implemented in the feature subset selection? We have seen whether the sensor values are recorded are similar between or among each other, which is nothing but correlation. What we have done visual correlation here, right? We have done visual correlation, and this visual correlation helped us to identify that machine, the status of the machine, whether it is in a good condition or not. But actually, in this data set, all our sets seem to be given as normal, but we have no choice of identifying the failures of the system. So that's why we will simply stop here by saying that we all the records are seem to be normal. All the machine pump is said to be normal. There are no problems. There are no failures in the machine pump as the data has shown. Any doubts here? As participants, this marks the end of this EDA session today. If you have any doubts, please let me know. Srinivas Reddy sir. Sai Kiran sir. Hello. Hello. Hello, Srinivas Reddy sir. Hello, Sai Kiran sir. The recordings will be shared with you once the coordinator does the download
Santosh
the.
sir, Santosh sir, already day one recordings has been shared, I think.
I like in the same lines, so they are asking for day two recordings too.
Similarly, but today night we will send, sir.
Yes, sir, sir. So, sir, this session has been ended, sir, from my
Okay.
side.
Still they are having any doubts, sir?
I have asked them,
Sir, in chat
participants.
box, they are asking your contact details.
So, yes, sir, I will simply share here. Please, all the participants kindly share, take a note of this.
All the participants, please fill up the feedback link, Amma.
Okay.
Sir, only feedback link is there.
Yes, sir, only feedback link.
Oh, okay, sir. Okay, thank you, sir.
So if then we will meet again in the tomorrow's session from 10:30 if there are no doubts. Okay. Okay, fine. Thank you.
Thank you, sir. Good session.
Thank you. Thank you.
Thank you, sir. Thank you very much.
Thank you so much, sir.
Thank you. Thank you.
Tomorrow morning, the session begins at 10:30, Amma. 10:30.
Okay. Thank you, sir. Thank you.
Okay, then, Santosh, sir.
Yes, sir. Thank you. I am leaving.
Okay.